So hello everyone. I want to present you our new speaker. Maybe you will hear him. You heard him 3 or 4 hours ago. I don't remember. Yeah. And now Andy Touch will tell us about very specific things, how to create shaders on Unity. So it will be a brilliant, I suppose, a brilliant masterclass how to do that. And it's time to begin.
1 sec.
1 sec. Okay. Okay. Maybe sing something. Yeah, about Unity and shaders and all this. Oh, a lot of guys here.
Tell a joke.
Tell a joke. Not today. Not today. I forgot all jokes.
Нет joke.
Нет шуток, говорит Энди.
Okay.
So yeah, okay. So let's start.
Cool. Привет. My Russian is terrible. I only know привет, спасибо, пиво. Da, нет, after party, yeah? And Unity, which I think is in Russian as well. So hi everyone, my name's Andy. I'm going to be giving a talk about how to write custom shaders in Unity. This is actually kind of a technical talk, but I'm going to try and make it as simple as possible. So those of you who don't know how to write code, you understand the basic structure. And those of you who do write code, you will cry with happiness. So there'll be tears, whether it's good or bad. Everyone okay with that? Da? Cool. Everyone's asleep. So my name's Andy. I gave a talk earlier on in this room about VR, and I am a content evangelist at Unity. So I use Unity's tools, create content, create games, create examples, and then I travel around Europe, Middle East, Africa, and Russia to basically show people how to create things with Unity. I'm on Twitter, and it's basically my name, but without a space, so it's quite easy to remember. So I'm going to be talking about shaders. So every time I do a talk, I like to ask people in the crowd more about themselves. So put your hand up if you're a programmer, or you write code, copy-paste code. Okay, yeah. Put your hand up if you're an artist. Okay, it's pretty cool. You do the coloring in. Put your hand up if you're an audio person, audio designer, or something like that. No one. Wow. Put your hand up if you work as a game designer. So it's basically your job to annoy everyone in the team. Yeah, you're nodding. Put your hand up if you work in Q&A, quality assurance. No? Okay, yeah, everyone should put their hand up, that's fine. Put your hand up if you make games. Okay, you come to the right conference. Put your hand up if you don't make games and you have no idea why we're all in this hotel. Okay, cool. Put your hand up if you've tried to write shaders in Unity before. Okay, cool. So this talk's going to be a ground-up talk. I actually have a slide for kind of the reaction. So before this talk, what the fuck is a shader? Some sort of wizardry. And then hopefully after this talk, you're like, okay, it actually makes sense now. I get it. I now want to experiment. I now want to play around with things. So it's basically my job to convince you with that. But it's very tricky, because shaders have kind of been this thing for many, many years, ever since computer graphics was first kind of a thing. And I'm going to condense down decades of research into 40 minutes, which is very tough. So the other thing that people are scared about in shaders, especially in Unity, is if you write an error in a shader, it returns a big hot pink image, or big hot pink pixels on the screen, which is very bad. Unless you're making a game for, that sort of art style, it's really bad in terms of shaders. So people can be quite put off by it. Also, they see stuff like this, and people get very scared unless you put your hand up if you actually understand kind of what this means. One guy there, he probably made this equation. So if you search like shader knowledge or shader algorithm, you'll probably see something like this and various examples. I'm actually going to avoid this. I'm going to do more of kind of a simple version so kind of everyone understands. You don't need to have studied computer science at school for 20 years before you can write shaders. So before this talk, what the fuck is a shader? Some sort of wizardry. I'll just look, oh, okay, it actually makes sense. So I went to Wikipedia, the most useful resource, and it said a program that tells a computer to draw something in a specific and unique way, which is actually quite true and quite accurate, especially in Unity. Unity uses shaders for everything that's drawn on screen. Some of the things you'll automatically have shaders applied, and some things you'll have to write your own custom ones. So a lot of people say, but why should I learn this? What's the point? Unity already gives me like 60 built-in shaders. I can copy-paste shaders online. And there's lots of reasons. So the built-in shaders in Unity are for generic use cases. They're not for specific things. Therefore, oh, I need a brick wall over there, or I need an object over there. Whereas with shaders and being able to know what they do, you can actually customize and tweak things and modify things how you want. You can do unique and custom visuals. So if you want to create games such as like Monument Valley and Journey, you may have to write shaders to do very specific things. You can do some really, really weird stuff in shaders. If you go on, has anyone been on Shader Toy? So Shader Toy is an awesome website where you go on it and basically people have written all sorts of crazy shaders, like they managed to like make a playable version of Mario in a shader, and there's some really, really crazy stuff. And you can see all the source code and take reference from it. Optimization, which is a very, very big topic. So if you actually know what's being drawn on your screen, you can actually cut out things. You know, in your match 3 game, Candy Crush clone, do you really need global illumination and shadows being drawn onto all the UI? Probably not. So you can dive into the shader and remove those things. So you can actually choose what you draw. Shader skills are gold dust. So part of my job is traveling around Europe, Middle East, Africa, and Russia, and meeting studios. And I always say, how many people here know how to write shaders, like properly? And I'd say 1 in 10 actually have someone. Like most studios kind of just, oh, we copy paste bits and stuff works maybe. 1 in 10 will actually have someone who says, I actually understand how shaders work. I know how to write them properly. So it's actually gold dust. If you're getting hired to a Unity studio and you know how to write shaders, they will love that. It's a very rare thing. Although after this talk, it's going to be less rare, but whatever. They aren't actually that scary. When you break down the concepts of the shaders, it's very similar terminology. So you have your variables, you have your functions, you have things like that. And they're actually very fun to play with. So I write a lot of shaders on trains and planes and get a lot of really weird stares from the old lady sitting next to me who has no idea what's happening on my screen. So in Unity, put your hand up if you use Unity, by the way. Who here uses Unity, like the game engine? Okay, cool. I was about to cry. So in Unity shaders, they're written using NVIDIA CG, which is C for graphics, but they're wrapped in Unity's shader lab. And it basically looks like this. So when you write a shader in Unity, you're actually writing 2 languages in the same script, which is kind of the first thing you need to get your head around. So you often have kind of the wrapping of the shader lab, and then you have the CG as the bulk in the middle. Now, the shader lab is purely to say to Unity, it's kind of the middleman. It's kind of to say to Unity, CG is doing this, draw this on the screen. And then when Unity goes back, it says, oh, Unity is doing this, put this into CG. And the finest way to look at this is if I go into Unity, not that one. Nope, yep, this one. If I go into Unity and select an object, everything you can see here, Shader Lab is drawing. Shader Lab is saying, oh, have a slider that does this particular thing. It's kind of the front end section of it. And we create it ourselves to be able to allow you to interface with CG. So you'll be able to do all sorts of custom stuff. And in Unity, we have several different types of shaders. So I'm going to talk about 2 very specifically, because I don't have, if I was to talk about every type of shader in Unity, image effects, compute shaders, all this, it would be like a 7-hour-long talk and everyone will fall asleep or get very drunk. I'm going to talk about 2 very specifically, vertex and fragment and surface, and they have different roles. So the easiest way to think about this is I was going to show like big algorithms, and then everyone's confused. So I'm going to put it in simple terms. So to write a vertex and fragment shader would be building a car from scratch. So we have here a lady putting a steering wheel into a car, but because the vertex and fragment shader you build it from scratch, you don't have to put a steering wheel in. You could make your car with 3 wheels and a squeaky clown horn, for example, and you choose what you actually put into the shader. And this is great for mobile, because if you build up vertex fragments from scratch, you can say, hey, I don't need lighting, exclude, don't write lighting into the shader. Or, oh, actually, I don't need it to do this complex thing. You can actually cut it out. So it's like building a car, brand new car to drive. Surface shaders is like buying a brand new shiny car, and it does all these things, but it's actually kind of tricky to compress it down into certain things. So for example, you could go buy a brand new car, and it would drive you from A to B and look very shiny and do these types of things. However, if you were to drive this around a go-kart course, it would be really, really bad. So that's why surface shaders on mobile is very expensive, because it does all the lighting, all the computation, all this very complex stuff. So I'm going to cover basically the source code of both of these things, vertex and fragment and surface, and kind of explain why you'd use one or the other. Being able to know how to write both is actually really, really useful. So I'm going to target vertex and fragment shaders. So basically there's a 4 or 5 step flow for how a vertex and fragment shader work. So the first one is it needs to gather the information to use. So in this case we have a model of a robot. So the shader needs to know what it's about to draw, in this case the mesh. Then you have the vertex function, because the vertex and fragment shader is 2 parts. It's the building part and then the coloring in part. So the vertex is where you'd draw all the objects, so you basically have all the pieces, and then the fragment part would then be coloring it in or making it look a type of style. So the first part is gathering your resources. So say if you're building a house, it's gathering the bricks that are going to form the house. Next part is then actually building the house. So you can see here you have the robots, not colored in because it hasn't got to the fragment part, but then you're building the house somewhere in the world. The next is the vertex to fragment function. So what this actually does is it takes a snapshot where it is on the screen and then draws it onto the screen. So it's like if I built a house, I then take a photo of the house. That's kind of that step. And you can see here you have the Unity blue around the outside edge. And then the fragment part would then be coloring it in. So you build the object, take a photo of it, and then you Instagram it and basically add filters or you color it in directly there. And then done. Your object is then rendered onto the screen. So it's basically that 4 or 5 steps. And you do those steps in CG. So for example, here you gather all the parts. So we have here a struct where we get the assets data. So in this case, we're going to get the vertices of the object, so every single triangle on the object. And the UVs as well for applying a texture. We also have here the vertex function. So you can see here that we're then going to pass in that app data, which you can see here, into the vertex. We're then going to build up our object. We then have the vertex to fragment function, which then takes the content that's in the vertex and then takes a snapshot of it, and it needs to know on the screen where it is and things like that. I'll explain SV underscore later on. And then the next step is the fragment function, which is just a fragment, passing it in, and then you have to then return the color of the pixel on the screen. So the simple way to think about this is the vertex function is kind of like a big for loop for every single vertices on your object. So every frame, it's going to go through every single point and determine what it's doing and where it is. Whereas the fragment function is going to go through every single pixel the object has on the screen and say, oh, this bit's white, this bit's white, this bit's red, this bit's blue, and it basically does that. That's why image effects are very expensive, because if you think about it, you're drawing all your objects in the screen, and if you apply an image effect, it's drawing them all over again, because it's already saying, draw this object as red, then draw it again in the image effect, so that's why they're very expensive on mobile. That's why transparency is expensive as well, because it has to draw the object, then draw the objects that you can see through the object. So 2 big for loops. And then it's done. You then return an end color for the for loop. So it basically looks like this. This is my Microsoft Paint skills right here. So we can see here we have the object data. They come through to the vertex. It's going to build the object. It then takes a photo of the object. It then colors in that photo, graffitis it, draws a mustache on it, whatever it may be. And then you have the object drawn to the screen. Everyone okay with that so far? Da or niet? Da, cool. That's basically the core basis of how the vertex fragment shader flow works. Now we also have here custom data. So this could be stuff that's not part of the object. This could be stuff like textures. It could be a script that passes a value into the shader. It could be taking an audio file and getting like the base of the audio file and pass it into the shader. It's basically all your custom data. And the custom data you can either insert here, such as, oh, I want to pass in an audio clip, and every time the base of the audio clip spikes, I want to have my object basically pulse out, so you actually have the object's shape based on the audio. Or it could be stuff like pass in this texture, and then it's going to overlay my object so it looks like it's covered in lava or water or something like that. So you can actually build up the object, then do lots of interesting stuff. So demo time. So I actually really, really hate PowerPoint. So I'm now going to show you how you can actually manipulate a shader. So if I go into Unity, I have here a cat, because I heard that DevGam has this new mascot, which is like an orange cat, which is on everyone's bags and things. And I know Larica likes cats, so I have an orange cat. Can everyone see that okay? Or maybe, okay. So we have here a cat. And we have here, as well as the 3D cat, we also have a cube of the cat. So what the cat looks like kind of in cube form. And we also have the cat if we ran it over with a steamroller. So it's basically what it looks like flat. So it's exactly the same material. So if I select my cat, you can notice here on the right-hand side that I have my material. So the material is basically a way of pointing to which shader to use. And we have here the standard shader, which is Unity's built-in shader that every object has by default. And the standard shader is amazing because it allows you to automatically have lighting, light mapping, global illumination. Basically, kind of 80% of use cases of a 3D object would use this. But it's very expensive because it does all these amazing things. So if you wanted to do a mobile game, using a standard shader is really bad because it does 50,000 things, and maybe you just want it to do 4 things. So if I go to the drop-down here, we have here all sorts of other built-in shaders. So I could go to nature and use like a bark shader, which would be built for bark and things. You can actually download these built-in shaders as a pack separately from Unity and experiment with them, break them, mess around with them, copy-paste chunks here, and I'll show you that at the end. But what I'm going to do instead is I'm going to go to a vertex fragment shader I've already written and kind of show you the source code of that. So I've already written it at custom, talk, unlit, unlit new shader. It's a very, very simple shader. And all it does is it takes a texture, such as this cat, and a color, and it puts them together. So it's like the simplest shader you could possibly make, or one of the simplest ones. So if, for example, I set my cat to be bricks, I could make my cat to be red bricks, for example. And you can do this like normal in Unity. And you can see all the content changing as well. But let's change it back, otherwise Larica will get very upset. Now let's change it back to here. Now what I'm going to do is I'm going to open up the shader. You can actually create brand new shaders in Unity by going create shader, and you actually have 4 different types of shader. One for like a surface shader, so the kind of expensive compute everything shader. Unlit shaders, the vertex fragment. Image effect would be like an overlay, and compute shader, I don't know anything about compute shaders, so I'm not going to explain that. So what I'm going to do is I've already written out the shader that I'm going to use, and I'm going to open it up. So here's the code bit, but I'll break it down as simple as possible. Normally I'd write this shader from scratch, but it actually takes a long time. So the shader begins with basically saying it's a shader. So we're on a good start already. And then basically saying how you can find it. So in this case, custom talk unlit new shader. And that's a really dull name. So I'm going to delete some of those bits, and I'm going to say custom talk devgam. And then, how would you say shader in Russian? How would you say cat in Russian? Oh, koshka. So how would you say amazing cat in Russian? I'll stick with koshka. Koshka shader. So custom talk devgam koshka shader. And that means that when I go back into Unity, I should be able to go to my cat, custom, talk, devgam, koshka shader. So yeah, so you basically can structure different folders. That way you don't have, if you write 200 shaders, they're not in one big list. You can actually make little folders. Really cool. So if I go back to the shader, let's see what it does next. So the next thing here is Shader Lab. And we have an element here called properties. And some people are scared of properties, but properties are basically variables. They're basically public variables to say, what slots do you want? And in this case, we have a texture, which is going to be wrapped onto the object, and we also have a color. And you can also do different things. I could say this is a koshka texture. And I could say, instead of color tint, koshka. Or how do you say color in Russian? I'm going to need you to spell this out for me. S-C-H... Yeah. Koshka. I'll buy Sublime later. So these are basically your variables. And if you think about it in this way, it would be something like this. So this is like the reference name, so what you're going to reference the variable later on. This would be like the display name, so what it actually says on the front end. So if you have artists that you don't want to touch shaders, you could do stuff like Koshka texture, don't touch, and stuff like that. So you can actually put little messages into display. Next is the type. So you could do things such as color, which would pass in RGBA. You could do floats like a number, and you could do 2D, which would determine it's a 2D texture, or 3D as like kind of a cube map texture. I'm going to use some later on, and I won't waste time on that now. And then you can set like default values. So here, the color is going to default to white, which is 1, 1, 1, 1, 1. You don't have to put that, but you could put that there. So it's basically, these are just public variables. Very simple. Okay. So what else is now? So next we open up a subshader. So subshaders are weird. Basically, you can have multiple subshaders in one shader, and you could do them for different reasons. So let's say you had one shader there for a game, for your character that's going to go on Xbox One, desktop, like Linux, and let's say an iPhone. So it's one shader across 3 platforms. Now, on the Xbox One and desktop, you want nice, beautiful lighting and graphics. On an iPhone 4, you don't want any lighting because it would be really bad in performance. So you can actually write multiple subshaders depending on your platform. So you could do like subshader one for Xbox, and then another subshader for like HoloLens and stuff, or subshader for PS4. You can actually write multiple subshaders, and Unity's clever, and they automatically find what platform you're on and assign it. What a lot of people do is they just write a separate shader per thing, so that way they're not scrolling through like 20,000 lines of code, and then they're in separate chunks, but it's really up to you. So subshaders are good for splitting up per platform. So next thing is a tag. Now, in Unity, we have lots of magic methods and magic words you can write, and they do lots of things on the back end. And tags and subshaders are the same. This is how you say if it's opaque or transparent. So if I set this from opaque to transparent, my shader is now transparent. So it's basically a cheap way of saying, oh, this is an opaque shader, transparent shader, this is a skybox, and stuff like that. And we have in our documentation like 50 different examples of these tags. Everyone okay with me so far? Da or niet? Yes. Go. I heard a niet. Yeah, sorry. So next thing is a pass. So a pass is awesome, but also very bad. So for example, in one shader, you can have like 3 passes, right? And then that will draw the object 3 times. Now, some shaders, you have to use more than one pass. So a good example is Left 4 Dead. Does everyone know Left 4 Dead? Of course. So in Left 4 Dead, those of you who don't know it, Left 4 Dead, you have an outline around your characters. If the internet holds out, and I can find any images of Left 4 Dead characters. Left 4 Dead characters. Okay, that's not useful at all. Left 4 Dead, dead characters. Okay. Here we go. So for example, in Left 4 Dead, you can see your characters through other walls, and they have an outline so you can see where they are. So that would use, for example, two passes. One to draw the character, like what they look like, the details, their clothes, and then you'd have another shader basically saying see through walls kind of as an outline around the outside of the character. So it would use 2 passes. That's great. The downside of that is every pass you use is an extra draw call. It's an extra element being drawn on screen. So I could write 3 passes and have amazing lighting in pass A, amazing lighting in pass B, and an outline in pass C, but then that object's going to get drawn once and again for every object that uses the shader. So my advice is try and condense things down into one pass, because then it's one draw call. Some shaders, like the Left 4 Dead one, you'd have to use a second pass, so you can't really get around it too much. So in this shader, it's just one pass. Everyone okay with me so far? Cool. Now let's get to the hard stuff. So when we write from ShaderLab to CG, you open CG with, if I can actually type correctly, CG program, and you end it with NCG. And that's basically tags opening and closing CG. And you stop writing ShaderLab and you start writing C for graphics. Now, a lot of this code I've already shown you in the slides. So at the start, we have to define the vertex function and the fragment function, and we have to name them. So I could call this vertex awesome function, right? And then that would be the name of that function. But I'm lazy, so I'll just call it vertex vert and fragment frag. So basically, like variables in methods in Unity, you don't normally have to say, I'm about to create this method in ShaderLab, CG. You have to say, I'm going to have this function later on. I have to write it, and I have to let Unity know it's going to be there and remind Unity, like, oh, this function's coming later on.
Sorry, if you just name it vertex instead of any custom name, will it be called it?
If you want to, yes, but generally it's bad to call like the reference name the same as what it is, like color or texture koshna koshka. Yeah, it's kind of a bit confusing. Yeah. So the next thing here is an include. So in Unity, just like you can have scripts or extra classes in a script, you can do that as well. So in here, we have a built-in CG include called Unity CG. And this actually does a lot of maths and imports a lot of maths in the background. So you could have an awesome programmer who writes an include file called like procedural generation or Minecraft spawning, right? Oh, wow, I can't even type today. I'm on the vodka already. So I could work with a programmer who writes a Minecraft spawning class, and then I can import that into the shader and then use it in some way. So and basically Unity CG allows you to do all sorts of complex maths. It's already pre-written in for you. Okay, so I'm going to get to the fun stuff in a bit. I'm still kind of doing the housekeeping stuff. But first we have the app data. This is like step one of that process. It's like get what you are going to build. So it's like getting the bricks to build the house. And in here, we're going to get the vertex of the object, and we're going to get the UVs. And we have here these kind of variables which are a bit weird. So you have here how many items that it's going to store. So in terms of a vertex has X, Y, Z, and W. So X, Y, Z, W. So that's going to be a 4. So it's a float 4. It's going to be 4 values. Same with something like a color. A color is made up of RGBA, so that's going to be a float 4 as well. So basically, you set the number of how much data you're going to store inside that little node. And you can have things, this is where it gets a bit confusing. You can have things called floats. You can have things called fixed, as you can see here, fixed 4. You can have also halves. So you could have like a half 3, a fixed 2, and a float like 10, for example. And this is where it gets a bit weird. So each of those determines floating point precision. So for example, with floats, you could have a number in the color, let's say the color with the R channel, it could be like 0.8999999 recurring and stuff, and Unity will then calculate that as a float. If it was a fixed, it would actually clamp it at like 2, so it would be like 8.99 and then stop. So it stop computing it forever. And half is kind of a weird one that's in the middle. I think it's like 3 or 4 steps. But you only really have to worry about float, fixed, and half if you're targeting like really low-end Android or really low-end like iPhone 4 and stuff like that. With some stuff today like the S6 or like the iPhone 6, you can write floats everywhere and it should be like okay, like it should be fine. And in the UVs, we're going to store an X and a Y. So here is then the struct that then takes the photos. This is takes photo of object. So then you can draw it. So v2f vertex to function. So you basically have to take that data and put it to the screen. In this case, it's the same. Now, for some reason, before position, you have to write sv underscore. And this is something that I think like DX9 came out, and then basically this was like a needed thing Microsoft said everyone had to put in their shaders, and it annoyed everyone because they had to rewrite, let's go in and add sv underscore in every shader they'd written. But it's something to do with that. And I think the PS4, you have to do it as well. It's 3 extra characters you have to do just to make your shader run on everything. So just write 3 extra characters. And I don't even know what SV stands for. The next thing here is we then have to take our variables. So we have up here, so main texture and the color tint. So Koshka tint and Koshka texture. And I hope I've spelt that right. And we have to say, okay, take it from Shader Lab and then put it in CG. So we basically take it and then we pass it into CG from one script to another script. So in this case, we're sampling the texture. In this case, we're taking the RGBA value and making it 4 values. Cool. This is where it gets a bit confusing. So we now have the build our stuff. So we then have the class that then builds up our object in a different way. And it's the vertex function. So this is basically where you determine where things are. So you could do all sorts of cool things with shaders. So I'm going to show you in a second if I have enough time. Yeah, I should have enough time. How you'd, for example, animate in a shader as well, which is really, really cool. And in this case, what it's going to do is it's going to output the vertex. It's going to use this thing called Unity _ matrix _ MVP, which is the weirdest bit of code you could write in an entire shader. And basically, MVP doesn't mean most valuable player. It actually means model view projection. So what it's doing is it's saying, where is the camera? Where is the object? And then it draws the position. Is it in front of the camera or behind it? And then we pass in the vertices. And then the UV we're passing in, and then we're passing out. So after we've built our stuff, we then color it in. Yay. Yeah. Da. So here we then have to get our texture, get the color, so the RGBA value, because remember it's like a big for loop looping through. We then have to then get an end color, and we multiply a texture by the color at the end. So we basically say, get the texture, get the color, get the pixels, and then we multiply them together, and bam, all that work just to output what color the pixel is on the screen. That's basically how you write a shader. So I've condensed about 40 years worth of rendering research, or 30 years of rendering research. You then end it, and that's basically the end of the shader. So at the end of all that, you then get a cat that then can go red or blue and things like that. Now, this is really cool, and we already have this shader built into Unity, and the reason why I showed you kind of the base concepts is that you can kind of understand this process of then going in and constructing and taking out different parts. So what I'm going to do now is I'm going to show you some things you can't do with the built-in shaders that you can do very quickly, because shaders allow you to do things very quickly and very complex in a particular way. So the first thing I'm going to do is I'm going to turn my cat into cheese. So I'm going to begin by going to and adding a, let's call this cheese texture. I can see, what's cheese in Russian? Sil? S-I-L or? S-R? S-Y-R. Oh, okay. Spasibo. So sir texture. I'm not going to bother with texture. So we're going to pass in another texture. And by default, this texture is going to be white. So you can set it to be default white or gray. Next thing we're going to do is cheese, or let's call this a dissolve amount. So dissolve amount. And this is basically, instead of like a texture or something like that, it's actually going to be a number, just one number between 0 and 1. So I can just write a float. So it's going to be one number. And then by default, let's set this to be like 0.5, because that's fun. So what we can then do is, now we've imported these two new variables, I can go into Unity, and at the front end, hey presto, I then have Sir texture, and I then have a dissolve amount. So you can actually add in these different parts. So when I go back into here, and if I scroll down, I then have to go to where I import in variables, so here. So I'm going to sample cheese texture. And because we just have one number, which is the float, it's just going to be float dissolve amount. Yeah, that's fine. And then we need to go to where we want. So I'm going to change the visuals of my object, not what it is. So this is kind of a bit weird. So instead of going to here and changing how we build the object, where all the points are, we want to change what it looks like. So you'd go to the frag. You're going to go to the fragment where it colors it in. And we're going to do this. I'm going to begin by taking, let me go to my cheat sheet on my iPad. I definitely don't have this here. And I'm going to go sear texture color. So we're going to get the color of the texture cheese in.uv. And we're going to use the same uv as before because we want to combine them eventually. And then the next thing that we're going to do is we're going to go down to here and using that importer class, because NVIDIA CG has a ton of magic functions that are all in their documentation, we can use something called clip. So what this is going to do is it's going to take one texture and it's basically going to use kind of the height map of the texture and cut out different parts depending on if the pixel is black or white, with black being cut out and transparent, white being not. It makes a bit more sense in a second. So the next thing that we're going to do is we're going to pass in sear texture.rgb, and we're going to subtract this by dissolve amount. And there we go. So if I go back into Unity, and let's pick a texture, let's pick, this is pretty good cheese texture. You can see here that it's actually quite jumpy between one value and another value, because basically the float is going to determine, clip takes between 0 and 1, so you can see here it's actually quite tricky. So it means that you can actually go in and in Shader Lab, you can say instead of a float, we can then set this up to be a range between 0 and 1, and then that will give you a slider. So your artists don't set a value to be negative 2 million, and then they say, oh, it's all broken and everything's gone wrong. You can instead put baby stabilizers on the cat and then change that. So what you can see here is, as I increase it, we then have a cat being cut up like cheese. So you can basically see what's happening here on this texture. So if I had set it to 0, it's going to do 0, but then as I go through, it's going to use the height of this type of texture. So it's going to go from the black pixel to the white pixel and up again. And you can see here, and it's going to cut it out. Now, I'm not very happy with this, partly because if I go to the cat, I can't see through my cat, because if you think about cheese, if there's a hole in something, you can see the inside. And this is where Unity's magic methods can come in. So what I can actually do is I can go to the magic methods section, of which I'll write magic stuff. And I can actually write something like cull off, so it turns off all culling of the object. So you can actually see now, we can actually look inside the cat, and you can notice that we can actually see through the object. So if I look at the cube, you can see we can see inside the cube. So you could do like a cage mesh and things like that. So if you're doing a cage, rather than building every single bar, you could actually just use clip and then cut out the cage like that. So it's a lot cheaper to do. Wow, okay. Very weird. I actually feel really sorry for the cat. So obviously we wouldn't ship a cheese shader into Unity, which is why I'm showing how you can do that. How much time do I have left, by the way? The boss isn't here, so I won't get in trouble. So what I'm going to do now is I'm going to show you how you can do something such as animation in Shader, which not a lot of people know how you can do. So what I'm going to do is I'm going to pass in extrude amount. So I'm going to make a fat shader, which basically takes all the objects and makes it bigger and smaller. It's really cool. So extrude. I'm not going to ask what Russian is for extrude. And let's set it to be like 1. So extrude amount. And then if I go down here, I've imported in one value. So I then have to go down to my variables, which is here. Oh, here we go. Float. Extrude amount. Now what I want to do is I want to get every single point of my object and then rebuild my object. So I'm not changing the visuals, I'm changing what my object looks like. So pop quiz for no prizes. Which function would this be, vertex or fragment? Vertex, yeah. I think we have some free swag on our booth, so you've won free swag. Everyone here can have free swag, so yeah, that's not much of a prize. So you can see here with the vertex, we can then actually, before we say, hey, go to the screen and look like this, we can actually mess around with it and actually break different parts of it. So what I'm going to do instead is I'm going to go to here where I get what I'm going to build, and I'm going to grab the normals. Normal. I'm then going to go down to here, and I'm then going to do something with the vertex. So in here, I'm going to say in.vertex.xyz, because we want to get every single point on our cat. So we're going to go to this point, this point, this point. Because if you think of it like a big for loop, it's going to start at like the first point and then cycle through all of them. So we're going to go to every single point. I'm going to add on in.normal.xyz, and we're going to multiply that by extrude amount. So what we're doing is, let's say this cup. So this cup would have a vertex at this point here. Now, that has a normal that's kind of facing out in this direction, for example. So we're basically going to say, rather than the cup scale, go to which direction it is and move in that direction by how much we apply. So if I then go back into Unity, well, okay, one sec. It instantly makes a big ball. Let me turn down the clipping, and then you can see that as I change the value, let's change it down to be like 0 to begin with. So if I set this to be 0.1, wow, okay. Okay, 0.0. So it's basically going to get every single point and then actually pull it out. So you could do all sorts of things with this. You could have like a tree swaying. You could move off the points. You could reset points. You could do lots of things. You could also do things such as like negative 0.02. You could have your characters. So you could go to your artist and say, could you please make it look like your cat or object has eaten a lemon, and you could have things dissolve inside and pull things out. I don't think we'd ever ship this shader with Unity. It's like a nightmare shader. And this is why I said you can do unique stuff, and also it's quite fun to play with, because once you have this basic setup, I could do all sorts of values. One thing I could do if I have time is take a texture, pass that in, so I actually determine the height of the texture. So I could have its eyes kind of cartoon style go root, 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 like this. You can do all sorts of really cool stuff. Now, the other thing I can do is, that's all working fine. Now, what I can do now is I can use a built-in class in shader called time, so it actually animates things over time. But rather than just applying time to it, I'm going to apply time using a sine wave. So it's going to go between, it's going to go to 0 to 1, to 0 to -1, 0 to 1, 0 to -1. So it's going to be a curve. So I want my cat to be pulsing in and out from fat to thin, fat to thin. So I could do this quite easily. In Unity, I can just write sine, and then wrap what I want to be signed, or sinned. And then I can write multiplied by underscore time. And this confused me for a while. Time is actually a float 4 in Unity shaders. It has an X value, a Y value, a Z value, and a W value. X being kind of half time, Y being normal time, Z being double, and I think W is like 8 times, which doesn't actually make sense, so just use Y. So what you'll notice here is it's then going to pulse. I'm actually quite scared what it's going to do. Okay. Whoa. Interesting. Why did this break? This is a fun thing with shaders. Even though it broke, it actually still looked pretty cool. Oh. I realized, yes. Sorry. So what I'm going to do is I'm actually going to multiply that by time.y. Okay, now it should do what I want it to do. So we now have a cat basically animated via the shader. And you can actually see that the box is animating as well. Like all the parts are, you see the box actually opens, like, and that's all being done on the shader, on the GPU, as opposed to, imagine if you went to your artist and said, could you animate this, please? Like pulsing in and out, and that would take a long time. Instead, with the shader, you can, with one line of code, you can then modify it and change it. Do all sorts of things. I could go to here and say, instead of plus this value on, multiply this. I actually have no idea what it's going to do. Okay, the cat completely disappears. Oh. Okay, I like it, but yeah, that looks horrible. And you can combine these things together. So for example, if I have my, whoa. Okay, let's set this to be like 0.1. Whoa. Okay, that's fine. That's fine for the time being. You can combine these things. Because you have the vertex function that's building up where the points are, like a big glorified for loop, and you have the fragment function drawing what it is, I can dissolve the cat whilst it's animating, for example. So you can actually have things animating and both dissolving and doing different things. So in a shader, you can do all sorts of really, really fun bits and pieces. So there's this one great example, Unity Vertex Shader Animation. This image blows my mind. It's one of my favorite, as nerdy as it sounds, one of my favorite images. With one line of code, they were able to animate, in this game, they're able to animate food if the Wi-Fi gives in. So basically what they did is they colored different sections of like food. So you can see here they colored some sections green, some sections red in the vertex channel. And they basically said the more green it is, the more it's animated. So here they have a chicken flapping. And the code to do that is literally 2 lines of code. You could probably trim that down to 1 line of code. So you've got time, you've got the vertex color. And they were able to do stuff like this. Yeah, this nice PowerPoint presentation here. But basically, you have every element of that burger bouncing up and down, all completely done in the shader, whereas the animator would have to actually move each part individually. And instead, this is one shader they put on, 2 lines of code, and it's automatically bouncing. It's quite incredible, like it's squeezing in and doing all this stuff. So with shaders, you can do very unique things. So, okay, so I've got my cats, yeah. So yeah, so you can do all sorts of interesting stuff. This looks horrible. If someone actually put something like this in a game, it'd probably be like a nightmare horror game. But it might be cool if you put that in. So next, so that's vertex and fragment. You build up from scratch. I was choosing what I include. Now, you can go deeper. You can add lighting. You can add cell shading. You can do all sorts of very complex things. So now I'm going to talk about surface shader, so buying the car from scratch. So surface shaders are amazing because they do lots, I like this term, auto-magically, because it automatically does magic. So they do things such as all forms of lighting in Unity. They calculate ambient lighting. They also calculate reflections, so water reflecting the sky and all that stuff. Unity has 6 forms of light mapping, which is crazy. It does all 6 of them automatically. And it does the whole PBR workflow of an emission map, a normal map, a specular map, all those things automatically in 41 lines of code. So basically, surface shaders are amazing for doing all this stuff, and you don't have to write any extra code. So for example, in the vertex fragment, you output every color pixel on the screen. Surface shader, you actually output what goes in the metallic channel, what's in the smoothness channel, what's your normal map, what's your emission map. It's a lot more easier to control what goes where, like how shiny is this thing. So for example, on the left here is the default surface shader that basically does all of Unity's lighting. And that's on the left. It's 41 lines of code, or 42 lines of code. Yeah. It's very similar in that you have properties. I'm going to show you an example in a bit. You have properties, you have different things, but at the end, you don't have a vertex function. You just have an end output of surface. On the right is if you were to write a vertex fragment function with a texture and just reflections of like one object, right? It's all out the code. If you were to write one light and shadows on top of that, it's all that code. If you were to write simple light mapping on top, it's all that code. If you were to combine all of those things, all 3 of those things combined would be a couple of 100 lines of code. It still doesn't even do as much as this does. So this does tons, but it's quite tricky to go into here and say, remove this, remove that. It's giving you a car, and it's tricky to take a wheel off the car and it still drives efficiently. So even though it does lots of stuff, it makes them massively overkill. So for example, for mobile, surface shaders are pretty much a no-go unless you're targeting, for example, like S6 or the iPhone 6 or high-end tablets. Surface shaders are too expensive. They're sometimes tricky to manipulate. So what I did with the clip where I dissolved the cat by like cheese and animated it in a surface shader is a bit trickier to manipulate and modify to do that. You could do it, but it's probably a bit more code. They're kind of Unity specific. So vertex fragment, if you Google like vertex fragment shader, you'd have all these examples of all these different engines and softwares that do that. Unity surface shaders are kind of like Unity's way of handling a surface shader, as every engine has their own way. And do you really need all those like emission maps and light mapping and stuff like that on your like Candy Crush clone for like a BlackBerry phone, right? You're probably not. So surface shaders are a bit expensive. But they do make custom lighting creation a lot easier. How much time do I have, by the way? 10 minutes, cool. So they do actually make plugging in your own lighting system or your own lighting visuals a lot easier. And every time I say this to someone, I say, surface shaders are amazing. You can plug in your own lighting and do stuff. I'd say 98% of people always ask me, how do I make a cel-shaded game? It's like everyone always asks me that. How do I make Legend of Zelda Wind Waker? How do I make Sin City in a video game? I'm not making this up. Everyone always asks me that. Luckily, it's like 5 lines of code. So everyone's now going to go make cel-shaded games. And basically, the process of the cel-shaded game is to take, for example, lighting, and rather than having the smooth fall off from kind of like white down to darkness around the side, so like a smooth curve. It's instead the process of passing in a texture called a color ramp and basically saying at certain points use this color instead. So it's almost in pieces. So for example, in Wind Waker, we have Link, and as opposed to the lights coming from the right-hand side and it being bright there and being dark on the other side, it's kind of like two steps. It's got just the bright side and just the dark side, as opposed to like kind of a smooth attenuation across the side. In Watchmen, I know this is the comic, but whatever. You have kind of like the yellow lighting close to the light, then kind of this dull sort of beige, then this orange, and then kind of like a harder red around the outside edge. So you kind of have that colored fall off. Luckily, you can do that as well, like here. And in this one, you just have white and you just have black. Everyone else asked me how to do this, so I'm going to show you. So if I then go back into Unity, yep, here we have animating cat. I already have a script pre-written, but this is exactly the same script that you do shader, standard surface shader. So I'm going to select this shader, talk, tune lighting, ramp shader. Okay, so the cat is a bit nicer now. And this is the default shader that Unity comes with when you create a surface shader. So you can do things such as set the smoothness of the objects. You can make it like super smooth and wet, which so many first-person games want to make everything look wet these days. It's weird. You can like make it like reflective, so the surface shader automatically handles reflections in your environment. You can do lots of interesting stuff. What I'm going to do is I'm going to go into the shader source code and explain kind of how different it is. And in some cases, it's almost identical. So we have up here shader, custom talk, tune lighting, ramp shader. So you have the same principle of like kind of that folder structure. So I could go into here and go Kroshka, and then devgam. Yeah, devgam, and it would create that same folder structure. Exactly what we've already covered, what you're already used to. Custom, talk. Okay, I spelt devgam with a space and devgam without a space. Sorry. So lighting there. So you have your file path still. Next thing, we have properties. Exactly the same as before. They're exactly the same concepts. If you have colors, you have textures, you have values that you pass in. You then have subshaders, the same. Tags. Here I've left in an LOD, so you can actually specify for shaders different LOD levels. So objects that are like 10 miles away, you could set not to cast shadows, but objects with a closer sort of LOD value do cast shadows. You have your CG program. But this is where it gets a bit weird. So rather than defining a vertex fragment, you instead define a surface shader. You then can set your shader model, so in this case 3.0. You then import in your variables. We then say what we're going to input. And then down here, you then have your vertex, or like your fragment of how you then draw the object. So in this case, I'm getting the same texture and then outputting it. Like we've done before, where you get the texture and you output it. It's the same thing. So what I'm going to do instead is I'm going to override this lighting with 5 lines of code, and then you have cell shading in your game. So the first thing you need to do is import your variable, because you have this process. Import the variable, import it to CG, then use it somewhere. It's kind of that 3-step process. So in this case, I'm going to pass in a texture of what the lighting is going to look like. I then go down here. I then basically say, don't use this. Goodbye. We're not going to use PBR. Let's call it, how do you say like cartoon in Russian? Boy. M-O-M-U. Okay. Okay, multi-lighting. Okay, cool. So we're going to say don't use the built-in standard shader, use multi-lighting. So we're putting our own one in. I then go down here. Now, because we're importing in a texture, I'm going to sample that texture, so the ramp, multi-ramp. Then in here, I already have, this is already in our documentation, I already have, for example, a lighting function. In this case, I've called it lighting tune ramp, and I'm going to call it what did I call it? Lighting, yeah. So I call it lighting, multi-lighting, but ignore that. Yeah. And then down here, I'm going to say, don't use standard, use this. And I'm just going to code comment out metallic and smooth, because I don't want metallic and smoothness, because cell shading doesn't really have it. So here it's got a couple of things that takes place. So we're determining a thing called n.l, and you need to understand n.l if you're going to do anything with lighting, because it's basically, you'll be using it hundreds of times. And I know I said I wasn't going to show you an algorithm, but I basically ignored myself. So here is basically what N.L means. It basically means the normal and the dot product of the light and where the light hits the surface. So if you think about this, this bottle, you have two values. You have the light coming in from an angle, and you also have the normal of the surface. And the dot product is where the light hits here, where this hits here, and it's basically the thing in the middle. So you can see here, that's why on this sphere, we have a light source coming from here, and the closer the light source is, it's basically going to hit it, and then the further the light source is, it's then going to have all these lines going around to say it's darker, it's darker, it's darker, because the normal's facing a different direction. Does that make sense slightly? It's kind of a big thing to talk about, but once you've got it, it's fine. So all we're going to do is we're going to say, rather than fade from one value to another, use this texture, and then it instantly will know at this point it's gray, at this point it's red, at this point it's blue. Very, very, very simple. And if anyone wants this shader, I'll then just, I'll Twitter it to you or whatever. Oh, it's broken because of reasons. So we then do that. We pass in the light direction normal. We then pass in that ramp. Everything is all fine. And then we then multiply it by the light color. And I realize that I'm getting towards the end of the talk, so I'll be very, very quick. So if we go back into Unity, I can then give a certain light source, and that is completely broken. Why? What? Okay, wow. If I rotate the light. Okay, that's a completely broken shader. This. Oh dear. Yeah, that's all fine. Duh. Wow, okay, I'm not really sure what it's doing. I was so certain it would work. Okay, never mind. Oh, here we go. Maybe that's the thing. Oh, okay, yeah, I've got it. I sorted it out. I was messing around with it and playing around. So if I remove the ambient lighting, you can see here, and let's say, just to turn off shadows, because shadows kind of get in the way, you can actually see here that as I rotate the lights, I'm going to basically use kind of that fall off. So if I go to the cat and I set this to be, let's say, we then have kind of cell shading. And if I add the cat's texture, you can see, whoop, that looks crazy. You can see that the cat now has cell shading across from the light side to the dark side. And you could pass in any texture. So I could pass in, for example, let's type in ramp. I could pass in like that color glow, weird material, rainbow lighting. So the lighting system now makes everything look kind of like that. So you can do lots of really unique things and play around with different instances. So for example, you could play around with audio, inputting like different bass values to the lighting and change and pulse things, which would be really cool. Or you could have things just look toon shaded like this. So yeah, basically the surface shaders allow you to plug in your own lighting how you want. I am aware I'm overrun by 1 minute. So what now? So we have basically everything I showed you is in our documentation. So if you go to our documentation page at Unity, we have pretty much everything I showed you. We also have the built-in Unity shaders. So a lot of people don't believe in this, but basically we take all of the shaders in Unity. So under Unity Archives.
Nice news. You are the last, and you can continue as long as you want.
That's a dangerous thing to tell me, my friend. Okay, it's all in Russian, so I don't know what I'm clicking. So for example here, one of these will say, Koshka, yeah. One of these things would say like download built-in. Which one is it? Like, that says cache server? No. So for example, here would be download built-in. And that would take all the built-in shaders in Unity, download them as a zip, and then you can mess around with them, see how they work. You could go to the tree bark shader and pull out tree bark and put it in the lighting system just to see what would happen. And those exist separately. So in Unity, all the built-in shaders here, such as this, like mobile, they'll all be protected. You can't modify those, but you could then take all the existing ones. So For example, I already have them downloaded because I don't trust conference Wi-Fi. It's interesting. So let's go. Let's make it bigger. So here we have all the maths library files. So you have all the lighting. You can go in and mess around with the lighting files. And we have all like the global illumination files, all these things. You have all the internal things we use to draw the actual interface. And here you go, da-da-da-da-da. All the mobile, so you can look at the mobile shaders, how they do lighting and things like that. And you can just strip out different parts and play with them. Another really cool thing with this is the pink error message that you normally get from a shader. So for example, if I write in some gobbledygook here, and then it goes pink, this is actually a built-in shader you can actually look at the source code for, which is under error shader. So that's the source code for the pink error shader that it uses to fallback. So you can actually replicate the pink error whenever you want, which is pretty cool. You can play around with it. So you can go through, dig through the shaders, see what they want. NVIDIA's CG documentation is surprisingly good. You actually have all the different functions and all the built-in things. So for example, I used clip to be able to clip the texture and clip and dissolve it. They have about 30, 40 other examples. And because Unity shaders are built off of this and include it, you can go in and use exactly the same code. Unity community, or as I call it, the Wild West, likes to share content, likes to share shaders. So if you go to the asset stored or the Unity wiki or Unify wiki it's called, or the forums, there'll be people saying, oh, I've just made the shader for Sin City, have it for free, and why not? And then basically they're very willing to share on how they create different content. It's quite amazing. Kind of like the bouncing food gift that I showed you. Like they basically just post the source code for you. And actually I find just Google searching not insert game name, but insert the game name you like, rendering techniques will actually get a lot of hits. So for example, Team Fortress 2 is one of my favorite games. So I just figured out one day, Team Fortress 2 rendering techniques. And guess what? Valve have written about 3-4 document papers on how they do all the rendering in Team Fortress 2. And they don't post the shaders, but they post exactly how they make them. Which is why I've got this image. So this is one of my favorite images. Basically, you have here one of the characters. And they basically go through all the steps. So you have your texture, you have your warp diffuse, which is basically what we did. We passed in that ramp. You then have like the ambient lighting, so you could use that. Ooh. Obviously, you don't use that. We then have this lighting, rim lighting, and basically you have all these documents. And events such as SIGGRAPH, which some people might have been to, people just go on stage. In Uncharted, this is how we did the entire rendering system. In Firewatch, or all these big games, on how they did all these type of things. People are very willing to share. They won't show their code, because obviously they don't want everyone to see their code, but they'll explain how they did it, and you can actually replicate things. And I think I have enough time. I just want to show you Shader Toy, although on this conference Wi-Fi it might be terrible. Shader Toy is pretty amazing in that it will allow you to create custom shaders and see all the source code. And people build entire games in shaders, and then you can see how they've built entire games. It's quite amazing. But I think the conference Wi-Fi is terrible. And once I discovered Shader Toy, I just spent days just trawling through it, because people have rebuilt the first level of Legend and Zelda in Shader Toy and stuff like this in a shader, which is crazy. Shader Toy is pretty awesome. You can go in and poke stuff. You can actually, someone wrote a blog on how to convert Shader Toy shaders into Unity shaders. So you can actually go into Shader Toy, see their source code, and bring them into Unity, which is pretty cool. So now, go and experiment. I always find it's the best way to learn. Go in, add one value, see what happens. If it breaks, oh well, it's fun. And that's the end of my talk. I'll be hanging around a bit afterwards out there, wherever Pivo, is it Pivo?
Yeah, Pivo.
Wherever Pivo is, I'll be hanging around out there. I brought a Gear VR with me, so if you've never tried like a Gear VR, I've got several games such as Land's End and things you can play with, and just come talk about shaders or talk about Russia in general and
about Pivo.
And Pivo, talk about Pivo. And thanks for coming along to the talk. I'll be here tomorrow as well.
Thanks a lot, Andy, for your presentation, for your masterclass. Yeah. Actually, Andy is the last speaker today because another speaker can't have a visa and he will not be today here. So сегодня вот это последнее выступление, так что можете к Энди подойти, спросить что-нибудь в кулуарах. Are you exhausted or you can answer for a couple of questions?
I can do some questions. It depends when you want to kick me out.
Есть вопросы у кого-нибудь? Есть вопросы? Guys want to ask you a couple of questions?
Sure.
Yeah, okay. Or you just can ask Andy peer to peer. Yeah.
Just come up and ask.
Yeah. Okay.
It's the fast thing. How do you
Is it possible to, without any heavy stuff, to do some kind of shadows for the mobile using these techniques that you described?
Yes, so to integrate shaders on mobile, you could use the surface shader, which is expensive. Other ways that you could do it is the shader code in vertex fragment is like very light. It's like 3 or 4 lines of code. It's very simple. Maybe I have it. Shadow.
Because the shadows, it's very...
It's very expensive because basically what the shadow does is the first pass it draws the object, so it draws the cat. Then the second pass would take the object of the cat, direction of the light, and basically will then multiply it onto the ground. So one way that people kind of fake shadows is to basically use kind of blob projectors. So they use a projector in Unity where you basically take a texture and you kind of project
and
it.
there is no tutorials about that, by the way, in the 5
Projectors?
in the Unity 5, yes.
The projector should be
because they switched them and now they're in the effects folder, I guess, and it's some kind of tricky with the prefabs. So if you could just show us.
Well, you have the projector component here.
Yeah.
It's exactly the same as 4, as far as I can tell. And you could do a blob texture, which would then be a faked outline of what your shadow would look like. I think League of Legends actually does this. So I think League of Legends doesn't have character shadows, but I can't remember. They basically just have a big black circle of where your character's standing. Mario does it as well. The newer ones, not so much, but yeah.
But would it be possible just to replicate the movements to have the shadow, behave as its caster?
So you could have a script on here, which would then go to the vertices, so go to the vertex, pull those points out, and then draw that as a second object outline on the ground, but flattened.
Maybe you guys should think about implementing
that would be cool.
some additional ways for the shadows, for the mobile, because it's real struggle right now. And,
that would be cool.
People suffering.
Well, yeah. It's just the nature of shadows is,
We can talk about it later because that's
Hello, can you show the source codes of this example?
Oh yeah, so just quickly, I was going to show you like 4 or 5 different shaders that do different things. So this one is the one I was talking about in kind of you have the outline.
Yeah.
So I have 3 values here. I have the width of the outline, the color of the outline, but that could be a texture for the outline as well, and how the actual, it's actually wrapped. So for example here I could have like, oh, hang on. Everything becomes a circle. So you can see here that I can actually increase kind of like the outline. So if my character's like this, it's increased. And I could also set the color, so I could set like the outline to be like red or something.
Yep.
Now the source code is actually quite simple. It basically covers everything that we've done before. So we have here your properties. In this case, you have the color and you have the float. And then we actually use 2 passes. So the first pass is the outline. And the first pass outline is going to turn off Z writing. So that means you'd be able to potentially see it through walls and stuff. We then use blending. So this is kind of like transparency. It's blending the background with the object and stuff like that. We then do the same thing. We then get the positions. But the interesting thing that you do here is what you do is you get a copy of the object. So such as you get the bottle, you then get all the points of the bottle, extrude them a little bit out, then color the whole thing one color, and then put it behind the thing. So you basically draw the first thing slightly fatter, and then color it, and then you draw the second thing on top of it. So it's basically making the same object twice, but one is green and slightly bigger.
Yeah.
And this should be in our documentation, or I just send you the shader in like Twitter or something. And then you just then return the color, and then the second part, the main pass, so the draw the cats, then does all the things.
Yeah, you just draw a main mesh and yeah.
So yeah, it's using 2 passes. It's quite, yeah, it gets a bit broken when you make it too big. But when you have it something like this, it looks quite cool. And you can also do all sorts of things. So if I turned off Z writing, 0.01, you can actually do all sorts of like, kind of like a red glow or a red fuzziness, or maybe the character is underwater, and then and as you look at, you can do all sorts of really crazy shiny stuff.
Yeah, thank you. But anyway, I have one more question. Maybe you know the easiest way how to create a water with transparency, with
For mobile, or
yeah, for mobile, without draw pass and stuff like that.
So water's quite tricky because
Yeah.
it depends on what type of water you want. If you want super realistic water, you can use something called use pass and then deform that. But on mobile, use pass is very expensive.
Yeah.
I'll explain use pass and grab pass first, then talk about kind of like a
Yeah, but grab pass, as you know, is very expensive, and not all devices support this way.
One thing you could do is you could have a camera for the water. It takes the snapshot or a projector, project the water, and then you use a shader that would then like deform what the projector is projecting. So you then deform like a texture, like kind of in the shader. That way you're not using use pass, grab pass. You're instead using another camera. And Unity can handle many cameras. So
Okay, maybe do you have an example?
I don't have an example of that.
Yeah, but maybe you can send it by email or.
If I make the example, I'll send it via email.
Oh, okay.
But what I was going to show is if mobile isn't kind of we're targeting, like you can use a thing called use pass and grab pass. So this is kind of like, do you know the Sims? And when your Sims get naked, I'm going to regret Googling this. Naked Sims pixelation. I'm Wow, okay. Okay, anyway, so everyone knows what I'm talking about. So in The Sims, you basically have your character, when they get nude, it has kind of like an overlay that's very pixely, right? And it changes depending on what your sim looks like, or what they're wearing, or whereabouts they are, and stuff like that. Now, the trouble with that is you could write a shader of what it's going to look like, but you don't know if your sim is going to have like a red t-shirt, or a blue t-shirt, or a green t-shirt. So you can use pass and grab pass to get the pixels on the screen of your object, and then almost overlay it again. So that's one way of doing water. So, but it's very expensive because you're basically drawing the object, getting the pixels of it, and then drawing it again another time. So that's why mobile for this is bad. But if you aren't targeting mobile, you could do something like this. So I made a simple example of this. So I have an invisible object. So you know in the movie Predator? So in Predator, Predator's not entirely visible. So Predator, invisible. Predator instead is kind of like in between visible and not visible, and is very refracted. Yeah, it looks kind of like...
yeah, distortion.
Yeah.
Yeah.
Kind of like that. So Predator's kind of like what it looks like, but slightly offset or slightly smaller. So I made a small example where I can basically pass in any texture. So let's say cracked. Actually, let's pass in a normal map because it doesn't like that. So you can see here, you can actually set how much it is, and then as I rotate around, you can see that as the object, if I crank this up, you can see that it's basically going to take, it uses every pixel, so you can see that it's the skybox. It then applies a normal map and then slightly offsets it. And it's like, I think, 2 lines of code, maybe. And you can pass
Yeah, but do you use grab pass?
Yes.
Yeah.
Yeah, so on mobile, this wouldn't be as efficient.
But how to avoid this way?
Pardon?
Grab pass. How to avoid?
How to avoid grab pass?
Yeah.
don't use it.
Yeah, and or simulate effect of grab pass or.
So to simulate the effect, you could have, for the objects such as the water camera, render textures to the water, what the camera's seeing. So you have a camera just for the water. In fact, I think that's actually how they do it in, do you know the game Land's End?
Yeah.
So in Land's End, I think they do that. So they originally tried grab pass. Let's find a good image. Yeah, so that runs on mobile. And what they did is, rather than using grab pass, for the reflection, they basically had a camera pointing up. You then got all the reflections of all the things, and then they then projected it down on top of the water. And then because they had the image of what the water looked like, they could then apply normal maps and bumps and all these different things on top of that. So they kind of used the thing, photo up to see kind of like that top point, and then project that top bit down, which is why you can see the reflection, and then they modified it. So they kind of used Unity's built-in cameras. I'm 99% sure that's how they did it, because I asked them and they said we avoided grab pass and used kind of a camera trick setup of up down type thing, which is kind of, and that runs, on like, it's targeting gear, which is like the S6 up, which is actually a good phone already, or S5 up. So that could be a technique. I'd have to set that up as like an example project, and then I'll put it on Twitter or whatever, or GitHub, I don't know.
Okay, thank you.
Yeah. So that's kind of like a trick. So with shaders, you could do all sorts of groovy stuff. So I'm sure if they set all the values down to 0, that whole thing would be like a reflective mirror, for example. I have another example of a so I've got this one here, and you can notice that that looks crazy. I have another example of a shader here, and basically what it does is it takes that dissolve, and if I can find it, it basically takes texture 1 and texture 2, and then you pass in your dissolve, so your cheese dissolve thing, and then you can basically set, so let's set this to be like, I've got like a pixelated, or like a noise texture here. You can see that as I increase the noise, it then blends between one texture and another. So that uses one pass. So you could use 2 passes, one for one state, one for another state. So if you have a game where you have a power-up, you run around as a normal character, instead of having pass A as normal character, pass B is kind of like your power-up of like glowingness or lava or water or whatever it may be, you can then instead combine them together. So you can see here, if I tone down the tiling, you can see here that it basically fades between one texture and another texture using a third texture all in one pass. Now I could fade it into like being bricks, like that. And the shader is actually quite simple. Basically, it uses everything that I explained and spoke about. So you have your textures, 1 and 2. You then have your dissolve. I then just use like a vertex fragment. And then when it gets down to here, I then use 2 things, step and lerp. So step basically says, it's like a if 0 or if 1 thing. It basically splits 2 values. So it says step the dissolve amount by the mask color, which is basically the clip texture, and then it lerps, which is standard between 1, 2, and 3. And NVIDIA CG, hopefully it loads. I don't know anymore. I'm scared. NVIDIA CG, oh, I've already got it there. You have, like, these are all built into Unity, and you can use all of them. So some of them we've actually used, like the sine wave, we've already used. Stuff like step is already there, and you go into it, and it will show you examples of what step does and things like that, and then you can apply that into Unity. So, yeah. Hopefully I can load Shader Toy, because I think now the conference has kind of ended. Hopefully people are leaving and not using the Wi-Fi. Yeah. There's another thing I didn't mention, which is actually quite important, which is actually getting C# scripts to pass values into the shader. Luckily, that is super easy to do. So if I just make a new script, Koshka controller, and open up the script. So it's actually really simple to do that. What you do is you reference the material. So in this case, the Koshka material, and you just drag and drop it in there. And then in your do thing, you can tell I'm writing code kind of like without any goal. You can then go to Koshka material, and then do like set a value, so either set float, set texture, set color, so in this case set float, you then pass in like extrude amount or cheese amount or whatever it's called in the shader lab, and then your value. Yeah, so you can then pass in data into there. So you can use set float, set color, set texture. This is why like I want to build a game where all the graphics are built up from audio files. So you analyze like an audio track, and then the bass sets like all the points and stuff. So everything's strobing to like the music that you're playing. So you can open up Spotify, play a song, and then depending on the song, as Adele, it would be a slow song. Metallica, it would be really hard level and stuff. And if you wanted to get a value, so let's say I've set my value like to 0.763, you can then just say, go to Koshka material.getFloat, extrude amount, and then you just need to pass that into like a float number equals, yeah, you then just get it the other way. So you set float and get float. We try to make it as simple as possible, depending on what you want to call it. So yeah, so you can do all sorts of wacky stuff, and yeah, that's basically it. Let's see, do I have any other crazy shaders? Probably not. Oh, okay. So I worked out a way that rather than using kind of like a reflection probe, so you need to place a reflection probe and it would take snapshots of up, down, forward, back, left and right, convolute those into a cube and then render it into the object. I found out a simple way that you can actually create a cube map elsewhere and then just apply it just as one thing to the object. So what we have here is we just have like a cube map, and then we instantly have kind of like a cube. So you can see like this cube. Okay, it looks a bit crazy, but you can see here that it's then going to have this object, and as I rotate it, it then rotates around inside the world. So if you're doing anything with kind of reflective surfaces, rather than relying on Unity's reflection probes, which every frame could be expensive, you can kind of make a cheap one and then do stuff like this. So I now have kind of like, and if you stare into it, you can see some really weird stuff. Obviously this object's not made for it, but yeah. So you can do all sorts of interesting things. You can pass in all sorts of data. There's one downside, there's two downsides that you can't do, but I think we're working on it. One is being able to pass in an audio file as kind of straight into the shader. You can't do that, unfortunately. You have to analyze it in a script and then pass in bass or whatever it may be. And the other thing that you can't do is kind of have an array built into the shader of like 5 textures, and then it uses 5 different textures. But you could do that in a script and then pass in that array to slots. But I think in Unity 5.4, I haven't played with it yet, you could specify an array, but only on like DX11 or DX12 or something like that, which I do mobile stuff, so I'm not really interested in that. So those are two downsides, because the audio thing's a bit too crazy, and the texture thing, there's probably some performance overhead of having a shader with 50 textures slotted into it for reasons. Yep. I've kind of run out of things to say. You have a question? Yeah. You can use the standard shader on mobile, but I work at Unity, and I'm going to say I advise you don't use it on mobile, because the standard shader is designed to be a generic shader that kind of does a bit of everything. It's designed to be kind of the terrain, like one standard shader on terrain. I think like the size of the object doesn't actually matter too much. Not too much. Like, because the shader doesn't really matter unless you're in the fragment function. You're doing lots of stuff. Whether it's small or big, it doesn't really matter in the vertex. In the fragment, it does. The standard shader is not really made for mobile. It depends what mobile you're targeting. If it's iPads, it should be okay. If it's low-end phones like iPhone 4 or the Android, profile it. Profile it a lot, yeah. Which does actually remind me, you can do something really cool in Unity. So not many people know about this, and it's quite a shame. I showed this to someone in Sweden, they started crying, so let's see. So I have here like really broken shaders and stuff. So what I could do is if I take my camera and align it to what I'm seeing, so in my game view, which is here, one sec. So what my player can see. Now, let's say, for example, I wanted to see how expensive this particular render is. You know, what shader is that using? How many vertices is that, or triangles? Is that quad? Is that cube, you know, transparent or not and stuff like that? We actually built in a feature which, ignore. We actually built in a feature called the frame debugger. I showed this to someone in Sweden, they started crying. And what the frame debugger does is you can dock it somewhere. So I normally dock it kind of just to the game view. When you enable it, it shows you a list of all the objects that you're rendered by the camera in your scene, the order they're rendered in, and what they're actually doing. So in this case, you have all the opaque geometry. This is quite a simple scene. There's like 5 draw calls. It's not that expensive. But you can see here that as I go through the slider, it actually builds up the objects one by one. So you can actually see, if you have lots of UI in your game, you can actually modify the slider and build it up one by one by one. So you can see here, let me just open a much more complicated scene. Which version of Unity am I using? I've got about 20 versions installed. Oh yeah, there we go. So if I open up my maze, so I've got a very simple maze example, which I used for my VR talk earlier on. That has more than like 3 objects. So I've got here this content in my scene. And let's just take my camera and like, let's just move it. Okay, so you can clearly see there's lots of content. And if I opened up my frame debugger and had a look at it, and then let's put it like, let's put it here and enable it. So you notice that we have 21 draw calls. And if I go through the slider, you'd be able to see all the different parts and how it actually builds up in the environment. So you can already see kind of what's being batched and what's not. So for example, if I begin, it places that ground and then places there. Maybe there's a game here where I can combine the meshes together. It then adds that ground. Maybe I could combine those 3 to be one big object. It then draws the background. I can't really do much about that. It then draws up like, so you can see here, it draws about 8 to 9 objects of the turret as separate pieces. So instead I can say, oh, actually make these one big piece, and then therefore one draw call. And you can see if I, like, for example, select the chassis, it will then tell you all the data about that type of draw call. So we have here how many vertices it uses. I think it even tells us kind of like, oh, it's using the standard shader, it has all these passes, tells you all the shader properties and all the values. So that's everything the standard shader is doing, whereas the other shaders I showed you, like the vertex and fragment ones, are a lot simpler. It tells you basically everything in this stack. Yeah. And you can see here the UI isn't getting batched at all. So, yeah.
What do you suggest for texturing, like huge meshes like terrains for mobile? What kind of maybe built-in materials to
What
would be the cheapest way to make terrain to look like standard standard?
Do you have an example of what your terrain looks like?
Let's say I took the Google map.
Okay.
I just made a screenshot of the huge area, 5 by 5 square kilometers. I put this map into the main slot of the standard shader. And then for the detail, I take another picture, this graph, I put it there, and I slide up the tiling number, and that's how it works for me to have overall picture and then some details on the third. And that is not the cheapest way to do it, as you say. What would be the more cheaper way to achieve that appearance?
That would be a cheap way to do it if you didn't use the standard shader. If you wrote a shader that just had 1 texture, 2 texture, combined them together, and you had a slider to determine how much they combined them, you would be cutting so much lighting, so much computation and stuff. You'd be saving a lot of performance. So the standard shader is great for being able to put things in, and it's great for most uses, but on low and mobile, the shader you've just described should be relatively simple. I probably have an example somewhere in the office, and if you just send me an email, I'll just give it to you. So the example you said would just be combining 2 textures. So yeah, so generally use as few materials as possible.
Like two textures in one material.
Yeah, that's great. Yeah,
That's all I mean.
yeah, yeah. Cool. No tears, unfortunately. But the Swedish guy, he was crying because he was the optimization guy. So he was like, oh, "This is the greatest thing ever. I can go through, and then we can fire our artists because these things are all separate objects and stuff." Yeah, it's pretty cool. It's quite interesting to see kind of how objects are built up. Cool. I don't actually have anything else to show now. I'll be wandering around for beer and stuff, so come say hi or whatever it may be. There's like 7 other Unity people here as well. Most of them Russian, so their Russian's a lot better than I am, hopefully. And I'll be here tomorrow as well. So yeah, привет. Spasiba. Yeah. And thanks to whoever missed.